Okay, so when we look at this quiz, okay, the first page actually overall was done fairly well. Some of you mixed up some angles. So one thing to mention is, right, if this is 40 and this is 25, then, right, to find this sliver here, you need to figure out these two should add up to 40, right? So this is 15 here in this sliver, this little red part. Some of you actually do it too. You use pen or something else to fill in what you find out later on. There's a 90 here at this corner. So we can use this right triangle. There are multiple ways. I actually enjoyed seeing how some of you solved it in a different way. I actually enjoy that because it's not just one way. Right? There's multiple ways. So you could find that this is 65, which in turn means that this is 115 because these are supplementary. Now that you have the 115 and the 15 in here, you can find that that's 50. So I basically just populated everything with the angles that I may use if I wanted to. My method was to go, right, sine of 65. So I used this angle right here over 87. Right? And then sine of 90 over y. So you got to make sure when you make your pairs that you stay within that triangle. You can't go 65, 87, and then 90, and this long one here. It doesn't work that way. You have to stay within your triangle. So some of you, I said, you're using a small triangle here and a large triangle on the other side. So just be careful there with that. So you get 95.99. That's the correct rounding there. Not 96. It's 99 actually. And then I use this y now. I move into this triangle here, right? I know that sine of 50 is going to be across from this side that I just found. So that's my pair that I start with. And then sine of 15 here, this one is across the side that I'm actually asking for, x. So this is what you should be getting. Some of you found this long piece and then the short piece and you subtract it. Hey, it's all good. It works. It works. So I enjoyed it. I enjoyed seeing how you solved it. Next, some of you, this is where you can tell some people that use their right brain or their left brain. Like some of you had this facing the other way, which is awesome. I like that too. But this is the first location where you look up at a 50-degree angle of elevation to the rock, and then you move 200 yards closer, look up again, and it's now 60, right? So that's the first location, second location. There's 200 yards in between. And so now I'm starting to fill stuff in, right? If this is 60, this is 120. If this is 50, 120, then this is 10, right? Some of you are actually showing me all the work on the side. I really appreciate that, actually. You're doing like the minus and all that. Very good. I really like that. And then you set up, right? Sine of 10 over 200, sine of 50 over x. So that would be the direct distance from the second location to the rock. And then to find the height, I simply use a slant. You have to use a slant. You can't use the base, right? You have to use a slant. So this times sine of 60 gives you the height of the cliff, right? So that's how you did that part there. So moving on to the more challenging part, perhaps. I would say 3 was still done fairly well. Some of you mixed up triangles. Some of you did not put the angle of depression with respect to the horizontal. So that would have, you would have lost marks there for sure. Some of you wrote down a different angle, like it's a transfer error. That I'm not too worried about. Okay, but this is what the situation looks like. That the boat, or sorry, the air balloon, hot air balloon, is between the two vessels. Right. This is the unidentified, and this is the cruise ship. Right. And so the way I chose to do it, a lot of you chunk this up. You use this right triangle, and then you use this one, and you just added these two pieces up, which is great. Can I just say something? When you have a height or a depth you're going to have to work with at least one right triangle at first. So notice how I did it. I chose this one here. I call this side X here. And I solved the diagonal, this one here. I solved for that. And then I used that side. Then I moved out to the large triangle. I went sine of 65 over the side I just found. And then I determined this is 80 up here. 80 corresponds to that whole base. And so I was able to find it that way. But it was cool to see that no matter how you did it, if you did it right, it's 17,050.1. Everybody got that if you did it right. The other side, like if you were to solve for this side, you would have had 9930. So I kind of had both of them there, but most of you chose to chunk this up into two right triangles. Nothing wrong with it. Maybe an extra step required, but not a big deal. This one I want to do from scratch. So I'm going to have this here. And I'm going to use a red pen to enter my additional information. So you just have to be very careful how you read this, right? It says a team leaves the airport A, right? You leave here. This is your start. And it says west 19 north. Guys, the first letter tells you where you're measuring from. West. So it's this line here. And if you need to extend it, by all means, you go ahead and do that. So it's west 19 north. So the 19 actually goes in here. A lot of you put it in here, inside the triangle, which is not true. Let me zoom in a bit. Because, and then it says that they're traveling 217 kilometers. And then they pick up the hiker, and then what does it say? It says you travel north 33 east, which means you measure from the north line and you move 33 degrees east like that. That's how the angle should have appeared at the very beginning. I'm just going to go ahead and say it. You will only be able to get one angle to come with you outside to the clean version. One angle, not two, not three, just one. Okay. And so the reason being is that this 19 here, this line and this line, they're parallel, right? So you can bring the 19 in here. Oh, this isn't going to work, is it? See, so this, you can extend this line, but it's the 19 goes right in there. Okay. And the 33, how's that going to help you? You have a 90 here. Between the north and the east line, you have a 90. So if this is 33, then this piece right here is 57. Right? You have the 19 there. And some of you, you know what, you tried something. Some of you went 180 minus 33 minus 19. But it doesn't work. It would only work if you happen to know this chunk outside and the 33, and you take these two away from 180, then you're left with what's inside. But that wasn't the case here. In this scenario, that was not the case. So alternate interior helps you to find this little sliver, and then complementary angles helps you to find this sliver, and then you can combine those two into a clean version. A lot of you put the 315 here, but it was actually supposed to be here. And I take part of the blame for that. You know why? Because I think you saw H. Oh, that's hospital. So I think what I'm going to do, I'm just thinking of it now. I think I'm going to make this out of 22. It's out of 23, right? I'll take the blame for that one. So I'll make it out of 22, which means your mark is going to go up by what, 2-3%? Something like that. When I enter it on my side, it's going to be out of 22. So I think it's fair, right? Teacher needs to take the blame. You need to take responsibility for your actions, right? Absolutely. But it was supposed to be, this is emergency. I went for E for emergency because H was for hiker already, so I couldn't use that one. But the 315 actually went here. And now you do your clean version. And I strongly suggest you use a ruler, even to extend the north-south lines and all that. So I'm going to try this here. I'm going to copy that one over here. This one. You got to shoot past it, right? Sorry, that's not the greatest, but there we go. So this would be 217. This would be point A. This is point H. This is point E. So this is 315 here. And then 1 comes with you, this one. If you add that up, you get 76 degrees right here, which is sine law, right? The question ultimately asks for the second leg of the trip. This is the first, this is the second, right? So this is what I was asking for. So you needed to do a lot of work. You needed to use this pair and this side to find that angle, angle E, which in turn allow you to find angle A, which in turn would allow you to find angle side X. That's why you lost marks for getting this wrong, because it would be a lot less work for you. So I wrote down less work. So -3 probably, -2.5. It depends on what happened here. Okay. So some of you went. If this is you, I'm not making fun of you. I really am not. 90 minus 19, so you came up with 71. You put that in here. But that can't be, right? 71 would be from this side all the way to this dashed line, right? That is 71. So it's not part of the triangle. Can't use that one. Some of you, actually, you did not do this wrong. Some of you did this. You put a north-south line here, and you brought the 33 in there. And that is true. The 33 is there for that sliver, but it's not the whole angle here for the triangle. So you can't really use it. It's only partial info. So I hope that makes sense. That part makes sense. I think I'm going to just show you how I solved it separately. I'm just going to show you the key here, because this was the biggest problem for you. And you know what? Don't despair. Try your best. Give me something. And if it's too good to be true, then maybe go back. It's like, which one doesn't make sense to transfer over? So here is the clean. Not so clean. Not as clean as some of you. I wish I had some of your writing style, because it's very neat. But so right, rough copy, clean copy. I use this pair, and then sine of E over 217. You got to use inverse. Don't forget about your inverse, right? Sine inverse, and you get that angle, and which in turn allows you to find angle A here, which is 62.05. Then I start with the same pair again, the pair that I started with. I use the angle I just found to finally solve for side X, and it's 286.78. I don't know if you want to write that down. If you want to try this again on loose leaf, good idea to do so. Okay. And now we're going to do the AC. We're going to just tack that take home AC right onto this, and you go for it. Okay. Fun stuff, eh? If there's anything you should take from this course, is that I insist on not giving up, even if it's not going well always, right? I honestly don't judge you at all. Nothing wrong with making mistakes, as long as you don't stay there. Let's see here. Because of time, I'm just gonna do the compass with you. The compass question, I'm gonna do that with you here. But here are the answers that you were supposed to have gotten if you did this right. I gave you a nice diagram. Look at those towers, right? Watchtowers. So the angles of depression need to go there as provided by the diagram, which allows you to bring that into the triangle's alternate interior. Yeah. Oh, sorry. I know I made changes to it. Yeah, sorry. This is the right one. Is that better? I made them pencil, but yours I changed the Word document. Yes. So are these the angles you have? Okay, good. That's right. That's right. The answers were ridiculous with the other angles, so I changed it. I don't like ridiculous answers that are unrealistic. So how are we doing here? There are the angles of depression. One more time. They come in. We have them in here. So there's a right triangle here. There's a right triangle there. Do you see the other triangle here? That one I formed later, right? But there is an oblique triangle here. What in the world is oblique? It's just a non-right triangle. It's not right. So what I did, basically, I just split it up. And you get 115 for x, and you get 164 for y. So that's, I don't know what else to say there. But after that, they're asking for, so this is B. C is calculate the heights of the towers. So you would use the slant, right? For each of them has a slant times the angle that touches it. Slant times the angle that touches it. So these are the heights of the towers right here. 340 and 462 and then some. We're good there? And then D, calculate the direct distance between the tops of the tower. So this here. You cannot use these angles, guys. As you can tell, the red one cuts through them, right? So you can't use those, but I use this one here because there's a 180, there's a straight angle down here. You can subtract these two to get that one, which is 147.7. And I use cosine law in this case. Just, I wanted to review it. You may have used something else. I don't know if it's possible, but there's side, angle, side. This is the resulting triangle. So for that, I get 2.79 kilometers as the direct distance there. So just make corrections. Basically, what I will do is, those of you that had a complete, I'm just going to give you full marks for that. And if you didn't have it quite complete, I will just deduct accordingly. And I think I'm going to let you keep this until tomorrow. You hand it in tomorrow, because that way you have this to study if you want to. Backside. Anybody have trouble with this one? I'll show you what it's supposed to look like. Right, it swings like this arm here. Anybody have this in their house? My grandparents had that, and it goes every hour. So when you're for a sleepover, every hour you're waking up. For 1 a.m. it goes ding, and for 2 a.m. it goes ding ding. So like, how do you sleep? But apparently they were just fine with it. They were used to it. But this swings through an angle of 12 degrees. And because the sides are the same, right? It's the same arm on this side than it is on the other side. And the horizontal distance is 14. So this is the triangle here that you're supposed to go with. And because it's an isosceles triangle, right, you go 180 minus 12. This goes back to chapter 2. 180 minus 12 divided by 2, then you get 84 on either angle down here. And then you can just go pair, and then sine of 84 over x. So you get 66.97 centimeters. A little tricky, but again, challenge is good. And then I'm going to do the last two from scratch. I just printed an extra copy for me. So follow along there. If you haven't done this, you want to make sure you follow here. A rescue helicopter flies south 37 east for 72 kilometers to rescue the first group of canoeists. After picking them up, you go south 40 west. So I go southeast and then I go southwest like this. So I'm going to start my diagram here. Compass rose. South 37 east goes like that. So I'm going to go, so the 37 goes in here. And then I go for, that's 72 kilometers. Then you're picking up and flying south 40 west. So again, your compass rose goes here. Southwest. So you're going 40 degrees this way. 40 goes there for 115 kilometers. Okay. And then what does it say? Until they reach a second group before heading back to the straight point. Okay, so here's a problem. This is a bit of a problem, guys. I don't like you thinking you line up perfectly, because then you think that 37 is going to be part of your triangle. It never says that we do. So because this is 72 and this is 115, you know what I'm going to do? That's why you need to be comfortable erasing. Okay. I did this on purpose, by the way, whether you believe me or not. You want to kind of shoot past, like you don't want to line up perfectly. So this is 40 here, and this is 115. Right? So this is your start, this is where you turn, and this is your end, so to speak. Okay? And then you have your resulting triangle. That's what I would say, hey, this is a good diagram. And now you're starting to bring stuff in. So this 37 is with respect to that dashed line, the south line. So you can bring this using alternate interior. This is 37. Okay, 37 is in there. You notice that the 40 is out here. You're paying attention, right? 37 and 40. Can I do the 180 thing here? Absolutely, because this is 180 and I have both of the outside. So to find theta, just go 180 minus 37 minus 40. So theta is 103. That is the key to success, that angle right there, because you have side, angle, side, right? You seem tired of this, right? Just get it over. I just want to write the test and let me move on, Mr. Dixon. I don't like compass. In fact, I'll never be in the forest, so I won't need it. Anyways, you never know. 103, and this is 115, this is 72, and side angle side. I'll give you the answer. I will post the answer as well, by the way, but it is 148.78. I hope you understand that right now solving is not the biggest issue, but remember how to do SAS, right? Remember how to solve using SAS or SSS, right? Like you need to still, we focused a lot on word problems, but still know how to just do the basics, okay? Review how to do the basics. Sine law, finding a side, finding an angle. Cosine law, finding the angle or finding the side, like which one am I going to use? Okay. Last one, and then you're free if you just pay attention to this one. This one, actually, I'm just going to refer you to this handout. Remember I gave you this handout here with the different scenarios? This is actually this scenario right here, the fourth option where you're going down the river. No, this one is going down a highway. You're going straight south down a highway. There's a lake here and you notice an island. You keep driving south and then you look back and you still see the island, right? The island stays where it is, but you're moving. So there's different directions to it from these different perspectives. Okay. So let's try that here. How does that? You're paddling down a small river. Biff spots an island at south 19 degrees west. So where's southwest? It's this way, right? Southwest. So I'm going to start here. This is my start. And you're going down river. It's basically due south. That's what it should have said, maybe more specifically. So you're going in this direction. Okay. But you're spotting an island at south 19 west. So I'm starting from the south line and I'm going to go 19 degrees west like this. This is the island. Okay. This is where the 19 goes. And then it says you continue to paddle due south, there is that word, for 1,500 feet until the island can be spotted south 80 west. So you're basically paddling down this dashed line and then you keep looking at it. So let's say you stop right there to take a look at the island. The south line continues indefinitely, right? But you are looking this way. And it is now south 80 degrees west. So the 80 goes there. Where does the 1,500 go? That's what you paddled. Like that. Some of you had this. I thought I saw a few of you with this. You were just not sure if that was the right thing. So because this is your north-south line, we know that there's a straight angle here. So this is 100. 100. Can we use the 19? I give you $100 if you get it right. No, I'm just kidding. Can we use the 19 inside the triangle? The answer is yes, because you're going down the south line, which is part of your triangle. So you may use the 19 here. This one comes with you. Very few exceptions, but this one does. When you have something due west or due north, south or something, you're actually on one of the lines that you're measuring from. Okay, so clean version, I won't use a ruler. Look at that. So 19, and because you know the other, that is 61 here. You actually know all three angles. This is 1,500. You have a pair to find sine law, right? This is sine law. What does it ask for? How far is Biff's second location from the island? So this would be the first location, second location, island. Use some kind of letter if I don't give you any. And so the answer is, if you want to know, 558.36. I would strongly encourage you to work through these because even though I'm not focusing on it, you still need to know how to do it. Okay. That's it for me today. So the mock test, if you want to go back, I think what I'm going to do is I'm going to see how many keys I still have from the booklet at the back. So if you want more, you know where to get it, right? It's going to have the page numbers attached to the key. And if you flip through the book, it's like, oh, I wonder how to do this one. You go for it. Maybe I'll say one more thing. Where is my trig booklet? Here. There's one that I didn't show you yet. The key is right in here. Where would it? Oh yeah, 78. If you go to page 78, the law of sines and cosines, it has a bunch of word problems there. And if you keep flipping, there's actually the key. That's not my writing, you can tell right away. It's not as neat. It's not as neat as my writing, right? These are the answers to those questions. So if you want to go through some word problems, you go to page, what did I say again? 78, yeah. Starting 78 if you want. Maybe just sketch it. Maybe even just sketch it and see if you know how to interpret the word problem. For previous units, I'm just going to have one of the three types of regressions for quadratics. Maybe I'll be more specific. It's either type 1 or type 3. What is that, Mr. Dirksen? Revenue, profit, or story. One of those two. So don't worry about fencing just yet. It's coming back, but not right now. Just focus on trig and then review that a little bit.